Good morning, good afternoon, good evening, everyone. Welcome to Automotive World. I'm Martin Carl. I'm the editor at Automotive World. I'll be moderating today's session. Thanks for joining us online for this webinar, which is all about AI-based perception systems in automated driving. I'm delighted to be joined by experts from Tata Elxsi and AI, who will introduce various approaches to perception systems and address opportunities and challenges for AI-based perception models. So what's this about? Well, the seamless functioning of multiple sensor-based perception systems is essential for automated driving. A reliable perception system should be able to extract data from the vehicle's surroundings and use it for planning and decision-making purposes. So the next hour is all about various approaches to available perception systems. We'll look at the role of AI-based perception models and associated challenges, guided by Dr. Gopinath Sevalraj, who is a Senior Technical Architect for Autonomous Driving at Tata Elxsi, and Stephen Lambright, Vice President Marketing at AI. As ever, we'll make slides and a recording of the event available afterwards, and if you'd like to ask a question at any time during the presentation, just type it into the Q&A box on your screen, and we'll address as many relevant questions as we can in the time that we have available. That's it. I'm going to hand over now for overcoming challenges for AI-based perception systems in automated driving. Gopinath, Stephen, the floor's yours.
Thank you, Martin. Yeah, I'm welcoming you to the Tata Elxsi headquartered in Bangalore in India. We connect the finer aspects of design, content, and technology to create great experiences for the consumers and exceptional outcomes for brands and businesses. We do consumer research, technology consulting, product design, development, testing for various industry sectors like transportation, broadcast, communications, healthcare, and next generation technologies. So this is enabled through a core team of 6,500 people for over last 30 plus years in business. And we work from different locations in India, and we service our global clients. If you look into the entire business divisions, we have been divided into 4 key business divisions. One is on the embedded product design, where we focus mainly on the embedded design, software development, and testing services. And the second one is on the industrial design engineering, which is ID, where we do mechanical design, prototyping, and simulation activities. And on the visual content part, we have a labs who will be dealing with animation, content creation, visuals, and augmented reality perspective. The last but not the least, the system integration and support activities is the 4th business divisions, where the activities related to all the system integrations for third-party solutions we do that. I'll get into the ADAS, which is the Advanced Driver Assistance Systems and Autonomous Driving Practice at Tata Elxsi. We have been working for the past 2 decades on the DSP systems, on 5+ years on the autonomous driving area, close to around 9+ years on the ADAS system development. And Tata Elxsi has been expanding its services to the OEMs all around the globe for about more than 35 different production programs we have been delivering with our OEMs. In a nutshell, we have divided our professional service offerings on image processing and sensor fusion, algorithm development, or development optimizations, and system vehicle integrations. It could be AUTOSAR on AUTOSAR perspectives, then vehicle validations, verifications on the cell mill, or lab-based or a field on corporeal systems as well. As well as on the simulation, visualization, and functional safety is all the other professional software service offerings from Tata Elxsi we do. As a part of our the 5+ years of research on the autonomous driving, we developed our proprietary software suite for autonomous driving, which we call as Autonomy, which has the building blocks for the different perception systems and the guidance and navigation systems, which are the core building blocks of the library of files, which can cater the different inputs coming from multiple sensors, and they do the processing of that at the perception level, which employs machine learning approaches or machine vision approaches, and then the guidance and navigation system will do the path planning, motion planning, and decision making, and then giving the proper actions to the driver system. So the key aspects of autonomy is a modular in nature, where each and every components which can be plug and place or replaceable with the OEMs, their own developed one, which can be replaced autonomously. And also it supports multiple combination of sensors, like from camera, LiDAR, radar. So if you look into autonomous driving technology, which has made a remarkable advances over the last few decades, especially over the last couple of 5 to 6 years, with the advancements of the machine vision combined with inputs from other perception sensors like LiDAR, radar, the automotive industry is trying to achieve high autonomy and eventually trying to achieve the full autonomy. Saying that autonomy is also licensed to one of the global OEM in Europe, where it has been tested for a level 3 plus connected autonomy on a test track as well as on the public roads. As a high-level architecture, I could provide that autonomy has the multiple building blocks corresponding to the perceptions, controls for the localization, and then vehicle connectivity, and data logging and diagnostics activities. As well as if I'm getting into a new sensors, the calibrations and configurations is also an important aspect which needs to be taken care by the software. So with a very little customization effort, the autonomy can be easily been implemented for. So in the high-level architecture, you have all these different building blocks which are there available as a part of the autonomy software. So now we'll concentrate more on the perception system as a part of this presentation, and then what are the different challenges that we are facing in terms of achieving that when we are talking about an AI-based perception systems. So the perception system has the multiple components which is coming from where it has to do the sensor data processing, where the data can come from multiple perception sensors like LiDAR or mono or stereo cameras, radar, and ultrasonic sensors. So the building blocks could be an object detection based on the camera images, or an object detection using a LiDAR point cloud. And at the same time, when the multiple informations are coming from different sensors, the challenges are how we are going to have the sensor fusion of these informations into it. So that's where we have implemented multiple deep learning based applications on the different object detection technologies as well as the classification approaches. And these modules have been also again benchmarked using certain benchmark data sets like Kitty or nuisance data sets, so that the perception system will perceive the world around the vehicle and then try to provide the on-road objects informations, and then the lane, or it could be a static or a dynamic objects like lane or a traffic sign or a pedestrian who is moving in the road, or it could be another car or a truck which is nearby. And at the same time, it will also provide the free space which will then further used by the guidance and navigation system for further path planning and motion planning into it. I'll quickly get into a video on the perception side, how the different algorithms, how it works. But if you look into this, the middleware component has the AI capabilities where we could be able to observe that there are object detections is happening here. Detect the multiple objects like a car, or it could be a truck, both at the 2D level. Even you can detect there's a pedestrian who is walking there, and there is a bicycle. So, and then there are 3-point cloud which is shown in the down where detections have been done at the 3D level. If you can able to observe that space which is getting extracted, which is nothing but the free space, and then the corresponding trackings which is happening at the map level is down. So this is giving the whole of how the perception systems are have been implemented in the autonomy. Now comes the challenges how we are when I'm having a multiple traffic signs of the it could be a different kind of a lanes which is there. I'm going to detect that not only the dynamic objects but also the static objects. So techniques like the lane nets, there are multiple convolution neural networks which has been used in terms of finding these objects, and they have been trained with multiple images in terms of identifying those objects in this case. So here, this lane model could also observe the bird's eye view and then filtered lane images as well as the performance parameters when the lanes are getting detected. Not only with respect to the autonomous driving, also the same functionalities can also be captured for lane centering ADAS applications. Saying that, what are the first and foremost challenge which we are trying to address it is basically the data preparation for the training. Because the data is the key for an autonomous driving when the perception models are designed using an artificial intelligence or machine learning techniques. And the second challenge would be how much the data would be required, whether the millions miles of runs would be an appropriate parameter for collecting all the data, even though whether it is covering a 50% of the scenarios or is it 100%. Again, there are questions where we try to address it using a smart way of annotating these or the data preparation first using a smart annotation tool is called a Tata, which is Tata Elxsi's proprietary tool. Where this particular block diagram which gives how we prepare this particular data sets, where OEMs or tier 1s are collecting the test drive data sets which has been storing in the data source. Now, before getting into the AI, we need to appropriately do the pre-selections or pre-labeling of that particular data in order to do that, the training. At the same time, it will also do certain automated annotations so that the initial level of data has been set. Once after that, the annotated data has to be verified. Again, there are a little bit of a manual validations will also be involved in that. And then if there are corrections which needs to be done, obviously it needs to be done in terms of verifying how well this data annotation has been done. Once all this process combinedly is done, then we could able to generate the data. Now, whether the data which has been created by the test vehicle or the collected from the test vehicle is not enough for the AI, because there could be many scenarios which might have missed out. So obviously you need to do certain kind of an augmentations, certain scenario creations in terms of that, the data as well. So that is what we call it the data generation part, so that you complete the entire data sets, which is annotated, which is nothing but the ground truth for the further usage at the training level. Either you could do the validation at the simulator level, or you could perform the training of the neural network, what you want to achieve at the particular application level. So the key aspect here is how we apply the AI-based systems or AI-based engines in order to do the key data annotation is effectively reducing the effort in terms of preparing the data. It can effectively reduce, say, about 60% when comparing with respect to the manual annotation perspectives. Maybe I can quickly show you how well the Tata tool and the AI-based engine which can be useful in terms of doing this automated annotation process. So here we see that there are multiple data sets which are available and the key informations which are also present over there. Now, we take the capabilities of this annotation. You can do the annotation at the images, which is in the 2D, by putting a 3D bounding boxes over there, as well as it can do the 3D point cloud annotations. And there are instantaneous segmentations, which is also possible over this particular AI-based tool. And if you can observe that there are traffic scene, which is nothing but the road or the road segmentation is also happening there. The bird's eye view can also be seen over there. In that. One more addition, that if you wanted to add more configurable objects, that is also possible with this particular tool using the configuration tool. Now quickly I'll show you that how when for each and every frames how the object are getting detected by the annotation tool, where the pre-trained neural network is keep on doing this object detections for each and every frames, and then all these different informations are getting stored in an XML format or in an Excel format, which you can able to download it or for your further usage for the neural network trainings or the AI-based engine trainings. So that's what I'm showing it here. For every frames, you will have a multiple objects, and then what is the kind of an objects, whether it's a dynamic or it's a static, and what kind of an environment that we are going to use it for that. So now this particular stuff which has been actually helped us are one of the technology. We have been the technology partner for our AI in order to achieve their 2D and 3D perception stack development. Now I'll hand over this session to Mr. Steve, who can able to now share his experience on how Tata Elxsi has been enabled in order to develop their perception system development for AI.
Hello, everyone. This is Steve Lambright. I'm from AI, and yeah, for me it's 7 o'clock in the morning, so I'll say good morning to everyone. Yeah, I want to talk a little bit about what our partnership with Tata Elxsi and what we've already done, and a few directional indicators of where we're going to be going with this. But first, let me just give you a sense of who AI is for those of you who aren't familiar with us. We are an artificial perception company based out of the Bay Area in California. We are the creators of IDAR, which we refer to as Intelligent Detection and Ranging, because we have an AI perception platform that is a system that leverages an integrated sensor that takes 1550 nanometer fiber laser and LiDAR and an agile LiDAR system, bore sights it with an HD camera so that we are marrying each 3D voxel with each 2D pixel to create a 2D, 3D combination where for each data point we're capturing both the RGB and the XYZ data as well as intensity, and combining that into a new data type, which we'll get into a little bit later, creates both challenges and opportunities when it comes to perception. We are backed by some significant venture firms. We've got some very good strategic partners, but most importantly, the system that we've created it gives us a software definable platform that allows us to achieve sort of what I would consider exceptional performance characteristics, such as being able to get 1,000 meter range, be able to have 100 hertz update rate, and what we refer to as high def resolution of 0.025 degrees, which you don't have to use. The point of what was different about our platform is you use the power as you need it, depending on how you want to interrogate a scene. Unlike every other system in the world, our system is agile and software definable. So you can redefine how you're scanning. You can do it deterministically. You can do it dynamically, depending on if it's a sort of a mobility type of application or something that's more ADAS focused, where functional safety is of higher concern. So anyway, we take a slightly different approach to perception and to the sensing platform than others do. So with that, we entered this partnership with Tata Elxsi to build a robotaxi platform that is built on the Tata Elxsi autonomy platform, but where we worked with them to optimize the entire sensor suite and leverage our unique capabilities in the platform to bring about an integrated 2D, 3D perception system. And really, I always think of this 2D, 3D perception as being one of those instances where 1 + 1 = 3, because you get the benefits of the two systems complementing each other and being able to support each other and sort of also address some of the blind spots, if you will, of the two systems. So again, the two systems work together. So we've worked with Tata to bring those issues together, as well as bringing together other data inputs such as the IMU, GPS, HG maps, etc. And we announced this at CES in January. We released a video showing what we've done so far. But this is an ongoing platform that we're working on, and you will continue to see additional progress being made this year. And if you attend several events later this year, you're likely to see us live and in person demonstrating some of our capabilities. So what does all this mean? As I mentioned earlier, one of the challenges in creating this that we basically threw at Tata Elxsi, and this is one of the challenges we gave them was, how do you develop and optimize a deep learning stack when you've got two significant challenges? One is our sensors capturing both the video or the camera images and the LiDAR at the same time. And we're, as I said earlier, mapping those 2D and 3D data points and integrating them together. So the system itself the perception system had to do two things. One, it had to do perception on the camera. It had to do perception systems on the LiDAR, and then it had to combine those two data streams so that we were able to achieve that 1 + 1 = 3 result of bringing those two data streams together. So that was one challenge. And then the second challenge, as I mentioned, was the fact that the LiDAR that AI creates is what we refer to as agile. But I want to demonstrate it demonstrates the sort of the nature of the fact that within a scene, we can adjust how we are scanning it with the LiDAR system. And again, that can be done deterministically at design time, or it can be done dynamically at runtime, depending on the preference and the mode of operation. So the challenge here again is we're not just a fixed scan pattern where the LiDAR is always the same. We can, via software, change how we're scanning. And of course, this makes a bit of a challenge to doing perception because the LiDAR is not, the power isn't being used the same. We're making trade-offs constantly on range, rate, and resolution in order to optimize each scene. So as you optimize each scene, how does that affect perception? These were challenges that we threw at Tata and asked them to help us figure out how to do it, because it's not, when it comes to perception, not an easy problem to solve. So the result of this, after working closely together, was a really powerful foundation for moving forward with this perception, where we're using both the 3D and the 2D capabilities to do everything from object detection to classification, orientation, tracking, doing velocity estimation, as well as ultimately doing motion forecasting, which is probably the most powerful aspect of this, being able to do not just knowing where the objects are and how they're oriented and being able to track them, but also being able to predict with some degree of reliability where they're going to be in the next 1, 2, 3 seconds. All of this was done live and part of the demo that we did at CES, as well as something we're continuing to refine and work on. Some of the things that Kapanath was mentioning earlier in regards to some of the more advanced capabilities we've now begun to introduce into our platform, and we'll start to see those roll out here in the next few months as well. So, as I said, it's a live system. It's continuing to grow and evolve, and it's one of those. It's only possible through the result of very close collaboration between the AI team and the Tata Elxsi team as well. So it's been an excellent collaboration, and like I said, we're not done yet. So with that, I'll turn it back over to you, Gopi.
Yeah. Thanks, Steve, to provide the the contribution that Tata Elxsi has made in order to achieve the complex 2D and 3D object perceptions task with respect to the LiDAR, which is going to be a breakthrough for the autonomous driving area, where an intelligent DAR could be a sensor which is a combination of both camera and LiDAR, which is going to be, as you mentioned, 1 + 1 = 3, that the complementary information which we will be achieving that. So that's where we try to use that automated annotation tool and the instantaneous segmentation tool in order to train the engines which is getting developed using the TensorFlows or PyTorch or Keras frameworks. And as Steve has mentioned, it's the work which is ongoing. And then, saying that there are challenges remains on how to resolve possibly when we are getting the conflicting information which is coming from multiple sensors. And at the same time, the question of how to gracefully handle the unexpected situations or unforeseen situations when an autonomous vehicle on the road, how it's going to handle that unforeseen scenarios. So these are all, again, a couple of challenges where even if you wanted to collect such data sets, where the data coverage is also not 100%, and there are unforeseens even after miles of runs. Now, if we can able to predict all these different kind of scenarios, and instead of getting into an actual data collection, but if we wanted to generate synthetically these scenes and then create those ground truths and then train the neural network so that the AI engine or the deep learning neural network, which is capable or ready for such unforeseen scenarios. So that's where I would like to propose, or I would like to present the synthetic scene generation tool, which is the next one, where you could able to create multiple scenes which we wanted to create instead of spending a lot of time over there in terms of collecting the data, whereas you could able to do it at everything at the lab level. So the scope of this tool is basically to generate automatically multiple scenarios which the autonomous driving or the autonomous vehicle is going to face, and create these ground truth data in a JSON format, which is a JavaScript object notation format, and then use this ground truth data in order to do the training of the neural network. So that's why the SSG tool is have been developed in order to solve that particular challenge of both data availability or data coverage or creating such unforeseen scenarios. So the scope is to create how to create the virtual environment, and it should also give certain user-friendly way that you can able to configure multiple scenarios, so that you can also add multiple 3D objects into the scenarios. So that's where we use that FVX 3D objects, which is getting used by the synthetic generation tool, and it uses an Unreal Engine, which is a game engine, where you need to get the photorealistic rendering images and then you're going to do that annotation. At the same time, it will also be generating the semantic segmentation outputs. So multiple solutions are derived from these SSG tools in order to make or generate these data sets for training the neural network. Maybe I'll quickly get into the video how this particular tool is getting used in terms of generating the synthetic scenes. The synthetic scene generation tool has multiple diverse environments which you can able to create, which is the photorealistic one where you wanted to create a road with different weather conditions, a daylight or a rainy situation or fog situations, how it looks like. And you can also have various vehicle models which can be ported into that, and then in order to create the critics or the objects for that particular scene. And you can also create multiple pedestrians or an animals. As I mentioned, the semantic segmentations is also another output which you can able to get it in that. Obviously, the ground truth data are getting generated for each and every frames using this object annotations. You can like appreciate the rendering effect which is getting over there when direct sunlight falling on the camera, how it gives that realistic images, or even when the vehicle is running at the night time, the shadow of the lights which is actually focused on the camera. And there are scenarios you wanted to create like pollution or adding rains and then adding a snow into that scenario. And if a pedestrian wanted to cross that road, or when how it looks like in a night driving scenarios. So in all these different scenarios, once you create it, you can create the automated ground truth data, which is in the form of the JSON format, as I mentioned, as well as the similar data which has been generated for the semantic segmentations as well. And once these generated data sets are available, then you can automatically use this for generating training the neural network for further processings. So this is one way of like addressing the issue of how we wanted to solve the unforeseen scenarios. Saying that there are much more challenges which is also bulleted over here when we go ahead for further generation or the next generation AI tools which are coming into that. When these engines are all actually are the AI engines what we are talking about for the perception models are all trained where you have certain kind of a supervisory or certain ground truth data are available. But is it possible to make the AI engines while running or while driving itself? It means it's already implemented or it's already deployed over there in an autonomous vehicle. How we could be able to make that to learn while driving itself. So that's again a challenge. There are unsupervised learnings, or there are unforeseen situations in which there are approaches like reinforcement learnings are the way forward in order to achieve these kind of challenges. The second challenge would be on the computation requirements when I'm talking about the next generation AIs, where you require a higher resolutions, images or higher resolution 3D point clouds, which is required in order to get the better estimate of the or better detection of the objects as well as the classifications. So obviously it eventually increases the computation requirements like the GPU requirements or the CPUs. So in such a cases, how we can approach this particular problem. One way of approaching that is which people are working on the neuromorphologies are creating a pulsed, or we call it as a spike neural networks, which is an SNN could be a possible an approach for or a replacement for a deep neural networks or a convolution neural networks, which could be the next generation AI perspectives, where the neuromorphology chips can also be do the computation with less power consumptions. And so again, these are all further challenges people are working on that. The third important challenge is how when a man is getting trust with respect to the AI engine, how we are going to make the building the trust with respect to the autonomous vehicle when an autonomous vehicle is running with an AI-based engines. Seeing all these different challenges when I wanted to make an autonomous vehicle to run in a real road, what are the different safety standards or safety level constraints which has also been addressed, like ISO 26262, or when I'm talking about the ISO 21448, which is nothing but the software or safety of the intended functions, where it classifies whether it is a deterministic processing or whereas the AI-based is entirely a non-deterministic processing, how we're going to apply the safety-related challenges. So these are all the multiple challenges which we need to address it when I'm talking about when we are going for AI-based engines, and so we are like working on that, and will still be like doing certain more research onto this in order to make the AI-based engine more realistic for autonomous driving. So with this, I would like to conclude the presentation.